Syntax directed definition is a context-free grammar together with attributes and rules. Attributes are associated with grammar symbols and rules are associated with production. This we studied, okay, in the last video. More formally, let us define what is syntax directed definition. Let us consider we have a production that is of the form capital A derives alpha, and this production is associated with a set of semantic rules, that is B is equal to f of C1 etc. Ck. So what is f here? F is nothing but the function, and either B is a synthesized attribute of capital A and the values of C1 etc. Ck are the attributes of grammar symbol alpha. This is what the definition of synthesized attribute. Or B is an inherited attribute of grammar symbol of alpha and C1, C2 etc. Ck are attributes of the grammar symbol of alpha or capital A. And you have to remember that each terminal symbol has no inherited attributes. Therefore, it is usual way to denote the attributes of grammar symbol in the form of x dot name, where name is a meaningful name for the attribute. So the process of syntax directed translation is twofold. Either by construction of parse tree, not only constructing a parse tree or syntax tree, but also we have to compute the values of attributes at each node by visiting the nodes of syntax tree. How to visit the syntax tree, that we'll study later. And one more notation, that is semantic action. The semantic actions are the fragments of code which are embedded within the production bodies by syntax directed translation. They are usually enclosed within curly braces. It can occur anywhere in production, but usually at the end of a production. We studied what is synthesized attribute and what is inherited attribute. Let us look once again. The synthesized attribute, it is defined by a semantic rule associated with production at the node. Attributes values are confined to the children of node and by itself. The non-terminal concern must be in the head of production. Always non-terminal it will be in the head of the production, and terminals also have synthesized attribute which are the lexical values denoted by lex val, okay, lex value generated by the lexical analyzer. So non-terminal is head of the production, and the terminals are also a synthesized attribute. So they are derived from the lexical analyzer. Okay, so what is the attribute here? Lex value. Look at the right hand side. So we have SDD. So this is based on our familiar grammar for arithmetic expression with operator plus and star. It evaluates expression terminated by an end marker n. Okay, so L derives capital E n. What is n here? It is a end marker. So in this syntax directed definition, each of the non-terminal has a single synthesized attribute. Okay, so what is that? VAL. Okay, value. We also suppose that the terminal digit has a synthesized attribute. So what is that synthesized attribute? Lex value. So which is an integer value returned by the lexical analyzer. So look at the first production here. The first production in the first row, that is L derives En. So what is the corresponding semantic rule? L value is equal to E value. Means L is a head here. So that is based on its children. Okay, E value. In the production 2, E derives E1 plus T, which computes value attribute for the head E as the sum of the values at E1 and T. At any parse tree node n, means capital N node labeled E, the value of E is the sum of the value of its children, that is E and T. And the production tree E derives T has a single rule that defines the value of E, to be the same as the value of T, means its child, right? So E depends on T. Understood? T value is copied to E. In the production 4 is similar to the second production. Its rule multiplies the value at its children. And the rules for production 5 and 6 copies the value at child, like the third production. But the production 7 gives f dot value, that is the value of digit, that is a numerical value of the token digit that lexical analyzer returned. Clear? So this is a simple arithmetic, okay, grammar, and the corresponding semantic rules are written. So each and every production has a corresponding semantic rules. Okay, so what is the attribute of non-terminal here? It is VAL. So it is very simple, and all the attributes are synthesized because whatever the head, okay, head non-terminal, I mean a root non-terminal depends on the value of its children. Clear? So this is what the synthesized attribute. About inherited attribute, it is defined by the semantic rule associated with production at the parent of node. Attribute values are confined to the parent of node, its sibling, and by itself. The non-terminal concerned must be in the body of the production. Look at this particular grammar. So the first grammar, that is D derives TL. Here L inherits from the T. Okay, so what is L? L takes attribute, that is INH. It is an inherited attribute, okay, that is obtained from the T, right? T dot type. What is T? T actually gets value, that is integer or float. Therefore, T dot type. Type is a synthesized attribute. Okay. So T dot type is equal to integer or T dot type is equal to float. So if it is integer, so that is copied to L. Okay. So that inherits from T. And L derives L comma ID. So this L1 inherits value, okay, from L. And what is ID? ID is obtained from, okay, lexical analyzer. So it is a synthesized attribute. Symbol T is associated with synthesized attribute type, and L is associated with an inherited attribute INH. Okay, this is an example for inherited attribute. So about the semantic rule and the grammar, so we'll discuss, okay, later the meaning. Now let us consider again the syntax directed definition of simple desk calculator. Now let us construct a parse tree for this. So look at the parse tree. It is named as annotated parse tree. So what is annotated parse tree? So annotated parse tree means the parse tree showing the value of its attribute is called as annotated parse tree. The question is, how do we construct this annotated parse tree and in which order we have to evaluate the attribute? So we studied that this particular grammar is synthesized, right? So each and every non-terminal has the attribute called synthesized attribute, and the evaluation is so bottom up. Okay, so bottom up parsing, that means reduction. Okay, the process of reduction. So we studied this example also. I mean, for synthesized attribute, we can evaluate the attribute in any bottom-up order, such that the post-order traversal of parse tree. Okay. So now let us consider this particular example, that is 3 into 5 plus 4n. So Look at the last production, that is f derives digit. So digit will accept the value from the lexical analyzer, that is 3. So down, parse tree, last value 3. 3 is copied to f value. This from t derives f and the corresponding action. So t gets value 3. Then again f gets value 5. So 3 into 5 will be 15. So 15 is copied to E value. Similarly, digital X value is equal to 4. 4 is copied to F value. F value is copied to T value. Now 15 plus 4 is equal to 19. So 19 will be copied to L value. Okay. So this is what the parse tree, I mean the order of evaluation. Now let us consider this particular grammar. So this is a grammar, I mean syntax directed definition based on grammar suitable for top-down parsing. But before that, let me explain actually what is this grammar. Look at the input. So what is the input here? 3 into 5. So how to obtain 3 into 5? Which is the start state here? T. So T derives ft dash. Right? T derives ft dash. So f can take the value 3, but how to obtain star? That is from t dash. What is t dash? T dash is equal to star ft dash. In this way, so we can compute 3 into 5. But what exactly meaning here? Each of the, listen carefully, each of the non-terminal t and f has synthesized attribute called value. The terminal digit has a synthesized attribute lex value. Okay, T and F has a synthesized attribute called VAL and F has a synthesized attribute called lex value. I mean digit has a synthesized attribute called lex value. And the non-terminal T dash has two attribute, that is INH and SYN. That is inherited attribute and synthesized attribute. So how many attribute for T dash? Two attribute. So the semantic rules are based on the idea that the left operand of the operator star is inherited. More clearly, the head T dash of the production, that is T dash derives star ft dash, means star f t1, okay, star f t dash. So which will inherit the left operand of star in the production body. That means T dash actually inherits the left operand from the left subtree. Clear? So this is what the concept here. See, look at this parse tree. Let me clear this. Look at this particular parse tree. So how the semantic rules are used for input 3 into 5. The leaf, I mean the leftmost leaf in the parse tree, which is that leftmost leaf in the parse tree, labeled digit. What is the attribute? Lex value. What is that? Is equal to 3, where 3 is supplied by the lexical analyzer. Its parent is the production number 4. Look at the production number 4. F derives digit. What is the corresponding action? F dot value is equal to digit dot lex value. Therefore, F dot value is equal to 3. Look at the parse tree. F dot value is equal to 3. At the second child of the root, okay, I'm talking about root, which is the second child, T dash. So, which has one attribute, that is INH. What type of attribute? Inherited attribute, which will inherit value from F. That is, T dash inherit is equal to F dot value, that is associated with production number 1. Look at the production number 1. So what is T dash inherited? That is equal to F dot value. So The left operand 3 for the star operator is passed from left to right across the children of the root. Got it? So 3 is the left operand that is obtained from the left subtree. Therefore, T dash has one special attribute called inherit attribute. So that will store that value 3. Okay, inherit attribute will store value 3. So now we have 3 also. Okay, we have 3. The production at the node T dash is T dash derives star FT dash. The inherited attribute T dash INH is defined by the semantic rule. Now what is the semantic rule? That is equal to T dash INH into F dot value. What is T dash INH? 3. Already we copied from the left subtree and just now we got F dot value. So how to get F dot value? That is from the lexical analyzer. So that is 5, right? Okay. 3 into 5, how much? That is equal to 15. What is 15? 15 is copied to now T dash INH. Understood? T dash INH is now 15. Okay, look at the production 2. With T dash dot INH is equal to 15. At the lower node for T dash, the production is T dash epsilon. What is the semantic rule? T dash synthesized is equal to T dash inherits. Now what is T dash inherits? You just imagine it is something like a variable. So what is the value now? Before it is 3, now after that it becomes 15. Now 15 is copied to T dash synthesized. So this synthesized attribute now contain 15 and this is copied to T dot value, that is the root node, right? Root node is T dot value, so that is copied to 15. Clear? So therefore we have importance for inherited attribute also. Clear? I mean this is just SDD, I mean syntax directed definition for top down parsing, a grammar arithmetic expression but top down parsing. So evaluation orders for SDD. A dependency graph is used to determine the order of computation of the attributes. Dependency graph. What is dependency graph? For each parse tree node, the parse tree has a node for each attribute associated with that particular node. If a semantic rules defines the value of synthesized attribute A dot B in terms of the value of X dot C, then the dependency graph has an edge from XC to A dot B. So it is dependent on child, right? From child to parent, we have one edge. Okay, arrow mark is towards parent. If a semantic rules define the value of inherited attribute B dot C in terms of value X dot A, then the dependency graph has an edge from XC to BC. Just we studied from left to right. So we have an edge. So dependency. Okay, just see the direction which is dependent on which one. So just draw the edge. Okay, very simple actually. So, I mean, to create a dependency, we have something called the data structure called dependency graph. Let me show you with the help of example. Look at this particular graph. Let me explain now the dependency between the nodes. Okay, the first one. So this is one, right? So 3 lexical value copy to F value. And after that, T dash inherits from F. Got it? T dash will store value 3, that is inherited from F. Next is this one. Okay, so 5 is copied to F, synthesized. After that, 3 into 5, right? 3 means T dash inherit into F dot value. This is what the action. Therefore, it becomes 15. That is copied to T dash inherits. That is equal to 15. Now it is copied to synthesized. Okay, T dash inherits is equal to T dash synthesized. So this is 15. So now again this is copied to T dash synthesized. Okay, so 15. And finally it becomes T dot value is equal to 15. So this is the dependency graph. Okay, for previous annotated parse tree. If dependency graph has edge from m to n, then m must be evaluated before the attribute of n. Thus, only allowable orders of evaluation are those sequence of nodes n1, n2, nk such that if there is an edge from ni to nj, then I less than j. This is the condition. Such an ordering is called as topological sorting of graph. Okay, so this is nothing but the evaluation is based on topological sorting. Now, so depending on that, we have two types of translation. Depending on the attribute, we have two types of translation. L attribute translation and S attribute translation. What is L attribute translation? It performs translation during parsing itself. No need of explicit tree construction. L stands for left to right. S attributed translation. It performs in connection with bottom-up parsing. S represents synthesized. Okay, so whatever we discussed in the previous slides, arithmetic expression. Okay, and some example like 3 into 5 plus something, right? So that example, that is nothing but S attribute translation. Okay, so bottom-up parsing as well as only it includes synthesized attribute. Therefore, it is S attribute translation. So let us study clearly what is S attributed definition. So syntax directed definition that involves only synthesized attribute. Okay, the definition includes only synthesized attribute, then it is called as S attributed definition. Attribute values for the non-terminal at the head is computed from the attribute values of symbols at the body of the production. Means children value computed first before the parent. So that is copied to parent, right? The attribute of S attributed SDD can be evaluated in bottom-up order of nodes of the parse tree. As I explained, this is nothing but post-order traversal of the tree. Okay, in S attributed definition, remember the evaluation is in post-order traversal. Okay, you just remember that post-order evaluation of a parse tree. So that is S attributed definition. S stands for only synthesized. So this expression, we studied this grammar as well as the parse tree. Now what is L attributed definition? The syntax directed definition in which edges of dependency graph of the attributes in production body can go from left to right, not from right to left, is called L attribute definition. Just we studied, right? Inherit attribute, inherited from F value. Attributes of L attributed definition may either be synthesized or inherited. It may include both, okay, L as well as synthesized. If the attributes are inherited, it must be computed from inherited attribute associated with the production head, either by inherited or synthesized attribute associated with production located from left to right, which is being computed, either by inherited or synthesized attribute associated with attribute under consideration in such a way that no cycle can be formed by it in dependency graph. Okay, so while computing, the cycle should not be there. Okay, in dependency graph should not contain a cycle. If it contains a cycle, so what happens? It enters into infinite loop, right? Okay, while computing, we should be aware that there should not be a cycle. So look at this particular grammar, that is t derives ft dash. So in production 1, the inherited attribute t dash is computed from the value of f, which is to its left. In production 2, the inherited attribute t dash is computed from t dash inh associated with its head and the value of f, which appears to left in the production. So from the example we studied this, right? Here we can conclude that this particular example includes L attribute as well as S attribute definition. Therefore, this is called as mixed attributes. Thank you.